Hey everyone, welcome back with a new lecture with accredited laboratory. This lecture will be very important discussion and also very important advice for beginners. When you come to the lab for the first time, instead of focusing on using instruments, it's essential to consider how experts developed and employed analytical methods. And this understanding will empower you to master these techniques for future application. I have noticed that every analyst comes to the lab. First question or first request from his side, please let me know how to run the instrument. But this is big mistake, because this is the easiest work, how to run the instrument. After that, you will have interpretation for the result and you will have many other things. But running the instrument is very easy work, very easy job. So please don't ask to run the instrument in the first week. He wants to be expert in running the instrument in the first week, but he will not focus on the most important things. But the most important knowledge you should have and the most important work you should learn from the experienced stuff is how these people develop their analytical methods, but from the scratch. You should ask the experienced stuff, how did you develop your analytical method? And then he will answer you, he will give you a complete process from the beginning up to the end. Through this process you will learn many things. And at the end he will give you also how to run the instrument and how to make interpretation for the result, and you will learn many things during this process. It takes time, but you should be patient. And if you focus on these things in the beginning and you listen more to the experienced stuff, he will provide you with a very good experience, and also after some time you will apply this by yourself. Then after that, if the technical manager asked you, please analyze these target analytes in this matrix, you will be able to do this. First point, you should find out what are the resources you have inside the lab. Very important, resources. Resources such as the instrument. First point, instrument. Instrument is very important because you want to analyze these target analytes in this matrix. When you will search about this, you will make your research, you will find that some people analyze these target analytes using HPLC, others use LC mass, others use GC. But inside the lab you have only HPLC. So when you will do your research, you should find the method to analyze these target analytes in this matrix using HPLC, because you don't have LC mass. So you should base your research on the resources that you have now inside the lab, and also on the budget of the lab, and on the chemicals that you have inside the lab and other assisted equipments. After you ensure the availability of all resources required to analyze these target analytes in the specified matrix, such as instrument, all chemicals and other equipments, and also standards. If you don't have standards for your target analytes, you should buy this from outside, from external. And after that, you should search for a reference method. Reference method, extraction method to analyze or to extract your target analytes from the specified matrix. Why reference method? Because the reference method is already developed and validated by a group of laboratories and published as a standard. So you can use this method easily to analyze your target analytes in your lab. But before that, before using this method, you should verify that you can apply this method inside your lab and you can get accurate result by this method. So first you should search for a reference or a standard method. For this method, you will make just verification. So if you found reference method to analyze your target analytes in the specified matrix, you will use this method. You will try to verify that you can apply this method inside your lab and you can get accurate result. With this method, such as if you open the standard method for water and wastewater, you will find different methods. These are reference methods. With each method, you will find some parameters, some performance parameters, method performance parameters. With acceptance criteria, you will apply all of these performance parameters. You should evaluate these method performance parameters and find out the acceptance criteria. If you found that your results are same like or within the acceptance criteria as mentioned in the reference method, so you can apply this method inside your lab. But if you didn't find reference method to analyze your target analytes in the specified matrix, you will go to develop a new method. You will make your research in the publications to find out what the researchers or analysts did before you to analyze these target analytes in this matrix. And you will find many publications. From these publications, you will try to find out what are the method which is fit for your purpose. And you will try to apply this method as it is. Or maybe from different methods you can select the method which is fit for purpose. This is lab developed method, developed inside the lab, or in-house method, as I explained before. Lab developed or in-house method. So don't think that lab developed or in-house method is a very hard job, because it's very easy, but you should learn at the beginning how to make the research. You should base this research on the resources that you have inside the lab, and based on that you will search for many methods. And you will select from all of these methods some methods which can be fit for your purpose, and from these methods, selected methods, you can modify these methods to get out the method, only one method which is fit for your purpose. So don't think that you will develop the method from zero, from the scratch, but you will have a base. You will have many publications for many methods to analyze the same target analytes in the specified matrix, maybe in different matrix, but from these methods you will make your modification to have the method which is fit for your purpose. And another example also for lab developed or in-house method, such as analysis of aflatoxin in nuts or spices or cereals. For that type of analysis, you will have immunoaffinity column. This is very important. With immunoaffinity column, you will find extraction method, specific extraction method that's already developed. You will try to apply the same extraction method inside your lab, and if you cannot apply the same, you will modify in this method, and after that you will make your validation. So for lab developed or in-house method, you should make validation, not only verification. You will evaluate all method or most of method performance parameters based on specific guideline, such as European guideline or whatever guideline. So you will select a specific guideline, and in this guideline you will have many method performance parameter and acceptance criteria for each parameter: LOQ, LOD, linearity, sensitivity, selectivity, ruggedness, robust, whatever. All of these method performance parameters that I explained before also in method validation course, you will find acceptance criteria, and based on these acceptance criteria you will say that your results are accurate or not using this method. And if it was not, you can make modification. And in some cases you will find company that will provide you with a complete solution. They will give you their instrument and other equipments required, and also the extraction method. They will develop a new method from scratch. They will provide you with this complete solution, and that will be very important, very good for them. Also they can, after that, they can sell this complete solution to other laboratories, and for you will have a new method from scratch and the instrument and also other equipments. So in this case also you have to validate this method. You have to evaluate method performance parameters to ensure the validity of results coming out by this method. But before running any standard or spike sample or CRM on the instrument to ensure the validity of the method, you should prepare your instrument to be ready to analyze these target analytes, and that will be through optimization process. Optimization will be different from instrument to another instrument, such as HPLC as an example. For HPLC, you have 3 points: mobile phase, column, which is stationary phase, and detector. First, you should select the detector which is fit for your target analytes, fit to detect your target analytes, and mobile phase and column. I will explain some points about this optimization only, but after that also we will have complete training course about HPLC and chromatography. Mobile phase and column. As you know that in column chromatography you have 2 types: normal phase chromatography and reversed phase chromatography. In normal phase, stationary phase and mobile phase. Your stationary phase is polar, which is the column, and mobile phase is non-polar. And the opposite here, in reversed phase, stationary phase is non-polar, mobile phase is polar. And based on this, you will select your mobile phase and the column. And mostly we will have reversed phase chromatography. Stationary phase is non-polar and the mobile phase is polar. As here in this column, and the mobile phase will carry the sample and move it through the column to the detector. The column, as I said, the stationary phase is non-polar. So all analytes will move through this column. On polar analytes will not be retained on the column. So it will not take longer time on the column because it's non-polar. And as you know that polar like polar and non-polar like non-polar. So polar compounds or polar analytes will not be retained on the column for longer time and it will move faster to the detector. But non-polar compounds will be retained more on the column and it will take longer time to be separated from the column, then it will be transferred to the detector. So each compound will be separated in a specific retention time. Here solvent front, then first compound, that polar compound, then polar, then non-polar compound, then non-polar compounds. These compounds will be separated at a specific retention time, will be eluted at a specific retention time, and this is the concentration. The area under peak is related to the concentration of the target analyte. So you can select the detector, which is able to detect your target analytes, the column, which is fit for your target analytes, and also the mobile phase. And after that we will explain in details also about the HPLC and the gradient or isocratic elution and mobile phase and the detector for HPLC training course. And also for LC-MS you will find another type of optimization, and that will be explained in another lecture. But for now you should know how to start in the lab. If you are a beginner, you should know how these experts developed and employed their analytical methods. Don't ask about running the instrument because this is very easy and you will know that at the end, but you should understand the complete process. Thank you and see you in another lecture.